Right, so the quiz on the board is just covering what you've done so far this lesson. Right, so you may need to show more working, but that's essentially the process. Right, don't forget you need to write, take the limit as h goes to 0, okay, each time until you are substituting it in. Show that substitution, okay, so don't just go from here and write equals 6x take away 5, okay, you need to show that you're making substitution when you take the limit.
How to do it.
Okay.
I didn't write down everything for some reason.
So, you may need to show some more lines of working, so I've done 2, 3 steps in one, okay, but that's in a sense the minimum what you need to do, okay. So, check that. So everything that's in the bracket at the end, when you substitute in f of x, should cancel with everything that's already out the front unless you have some more interesting function. And when I say more interesting, it might involve square roots, and it might involve fractions with the variable on the bottom. But I would not expect you to have one of those questions. I expect you to have some sort of polynomial. And I think your data extension one, we can actually communicate with you from extension one principles. Okay, this morning I'm most interested in this one. Alright, so looking at that answer, what does it tell you? I'll say this pretty much every single lesson. Missing one thing there. Equation of the gradient of the tangent to the curve. Okay? Doesn't give you the equation of the tangent because you need to do an extra step. Okay? So that's what the process of differentiation does. Alright, question 3. A. So we need to differentiate. Okay, so I wouldn't expect them to ask you to do that by first principles. Okay, I wouldn't actually expect them to do that. Alright, however, we have learnt, of course, we have learnt our short ways of differentiation to be able to answer these questions nice and quickly. Alright, so what is y dash? Yes, when you differentiate, so half x to the negative a half. So remember, when we have a third, okay, we introduce fractional indices, okay. The third power goes on the bottom of the index, and the power inside, okay, goes on the top. So the square root of x is equal to x to the half. Okay, then we use our rules, we bring it down, multiply by any coefficient, okay, decrease the power by 1, okay, that's what we've done here. But the next step you need to do, because the question is written specifically as third, means you need to also write your answers specifically as a third. So 1 over 2 x to the half, when you use your index laws to bring down the bottom, 1 over 2 times the square root of x is the final answer, okay? So if you stop here, you may not get your full marks, okay? So make sure you're putting it back in the format of the question. Right, B. Y dash. So what's the process? This one.
You let u equal.
Oh, no, this one.
Okay.
Let u equal 2x plus 3.
Yep. We can do it that way, or we can do it the quicker way, Kyle.
Oh, I forgot the quick one. No, I didn't like that one.
Didn't you? It's essentially the same process as this, what you've done here, but the only difference is you need to multiply by the derivative inside the bracket. Okay? So, bring the power down. Y dash is 5 outside of everything in the bracket. Decrease the power by 1. And then multiply by the derivative inside the bracket. Okay? That's the only extra step when you have a function of a function. Alright, so it equals 10 outside of 2x plus 3 all to the power of 4. Okay, now the other method, so I'll quickly cover it. So y was 2x plus 3 all to the power of 5. We let a variable, usually u, equal what's inside that bracket. Okay, that means y is going to be u to the power of 5, and we have what's called the chain rule. Okay, so if you're doing any sort of mathematics at university, okay, you're going to be told about the chain rule a lot. So that's why I'm covering it now. So what you're doing in a sense here is you're applying the chain rule, just not in this method. Okay, so dy dx is another notation of the first derivative. So we're differentiating y with respect to x there. dy. Okay, so I've got the same fraction there, and if I put the same thing here and here, okay, that would be like I'm cancelling it and get back to this original form. So I'll put my variable in there. So dy, differentiate y with respect to u, which is this equation. So we're differentiating this. It'll be 5u to the power of 4, and differentiate u with respect to x. So here's my equation u and x's, differentiate x, and I'll have 2. Okay? So equals 10u to the power of 4, and then you substitute back into u. Okay? Which is the same answer. Alright, so either method, if you're differentiating a function and a function, will get you full mark. Okay, so you need to decide which one you're going to use. Okay, so you remember the process, or you remember the setup of that one. Alright, any questions on any of those? Yes, no? Alright, next, product rule. So we're going to cover today's product rule and what's called the quotient rule as well. So another 2 concept methods you need to know. So 8.8. Product rule. On page 66. Alright, so we've had we have learnt the method to differentiate a polynomial of any degree, okay, as long as it matches the definition of the polynomial. We have also looked at different forms of indices, so differentiating surds by setting it up using our index clause. And we have covered function and function, so we have a polynomial or to the power of another number, okay, because it's going to take too much time to expand everything so that you have it into a polynomial. However, you two will be learning that process starting your HSC course for extension 1, okay. So, product rule. So, this is in the form when we have a y equals some function of x times another function of x. Okay? So that's why it's called the product rule, because you are having the product of two functions of x. Okay? One way we can do this is we can use our expanding rules that we've learned in the second chapter, or we're going to follow the rules from today. Okay? Now, if y equals that, y dash, okay, so this is the process. And I'm going to quote something, so hopefully you will all remember. Alright, so g of x times the first derivative of f of x plus f of x times the derivative of g of x. Okay, this will become more clear in a moment. So, the way I have learned it and the way I'm teaching you, okay, is my maths teacher actually used to quote this sentence, alright? If the f of x is the first function and g of x is the second function, okay, the process is this. The second multiplied by the derivative of the first plus the first multiplied by the derivative of the second, okay, and that will become more clear in a moment. Alright, let's look at some examples. Differentiate the following. So x squared plus 3, 5x plus 1. So, we will, yep. I'm just talking it through while giving people a chance to write it down. Alright, so we have two different functions of x, or they can be the same function, okay, of x being multiplied by the use of the bracket, okay. Now, yes, we can expand this using our FOIL and then differentiate our polynomial. However, they won't always be straightforward like this, okay, because you'll have other powers associated as well. So, we will try and learn this method. So, this is f of x, the first function is f of x, and the second function is g of x. Alright, so y dash, so this is really y equals. Okay, so it equals this g of x times the first derivative of f of x. Second times the derivative of the first. Okay, so the derivative of the first, I'm just going to put it out the front. Actually, I'll do it in the order I've just said it. So, second, the 5x plus 1 times the derivative of the first. Okay, which is 2x. Plus the first, x squared plus 3, multiplied by the derivative of the second.
5.
Okay, so multiply by 5. Okay, and that is your derivative function. So, I'm just going to tidy it up a bit. So 2x outside of 5x plus 1 plus 5 outside of x squared plus 3. Okay? So essentially write the derivative out the front because there's usually less terms in it. Okay, you don't need to do any more with this. I'm not testing you on your expansion skills here. Okay, we're getting assessed on whether we can differentiate using the product rule. Okay, further on in other sections of work, yes, you will need to do something more, but just when you're differentiating, we can stop there. Okay? B. So x, so y equals x outside of 2x, take away 1 to the power of 6. So we're stepping up already. This is an example of the product rule because you are multiplying two functions of x with each other. Okay? So the x out the front is your f of x, and this part, 2x take away 1 or to the power of 6, that is your g of x. Okay. First times the derivative of the second. Sorry, other way around. Second times the derivative of the first. Second, start at second. So second times the derivative of the first. Alright, so the derivative of the first is just 1. And that's the second. So we have 2x take away 1 or to the power of 6. Times 1 plus the first times the derivative of the second. Okay, so the first is x, f of x is x, g of x. Alright, remember how we differentiate? We just did the quiz. So you bring the power down, write that again, decrease the power by 1. So, you can finish it? Oh, good. Multiply by the derivative of what's inside that bracket. Okay, so bring the power down, rewrite what's inside the bracket, decrease that power by 1, then multiply by the derivative inside the bracket. Okay, so until you learn the method, okay, you will probably take shortcuts and write your answers down straight away. But while we're learning it, I'm taking an extra line to make sure you all understand. So it equals 2x take away 1, or to the power of 6, plus. So you've got 6 times 2 with an x out the front. So 12x, and multiplied by 2x take away 1 to the power of 5. Okay, so once you get more comfortable with the process, we can go straight from the question, go straight to here. That's fine with me. Okay, but you need to know the process and follow it, okay, before you can decide to take a quicker approach to it. Right, is everyone following the process? Everyone understanding what's going on? Is there any questions about this? There is a question about it?
No, sorry,
Alright, let's try the last one. C.
this one.
4x times the square root of x plus 3. So use this rule when there are two functions of x being multiplied with each other. Okay? Not when they are added, because we've covered that in an earlier lesson. We just differentiate term by term when they're adding or subtracting between terms. But when we are multiplying, we need to use the product rule.
Are we splitting it so that 4x is the f of x and the square root? We have to do the
Yep.
differentiation, so it's like x plus 3 to the power of a half.
that should be the way we need to set it up, yes. So, just to go back on my first point, we can expand this nice and easily and then differentiate it term by term. Okay, and we'll get the same answer if we were to expand this out. Okay, however, trying to do the same sort of thing here and here, expanding, it won't be efficient. Okay, so that's why we need to learn that rule. So, y equals 4x outside of x plus 3. And what was the power again? Half, okay? So the square root being an index of half. And it's going to be exactly the same process as this one here. Right, the start of the second. Second, multiply by the derivative of the first. X plus 3 is a half. Multiply by the derivative of the first, which is 4. The 4x, sorry, that's your f of x. And x plus 3 all to the power of a half, that is your g of x. Plus the first, so the first being f of x, multiplied by the derivative of the second, the derivative of g of x. Okay, so once you get comfortable with the process, we'll be able to take some quicker approaches to you. But I would suggest until you get there, we're writing it out as it is, and then we tidy up next line.
You have to times it by
The derivative inside the brackets. I'm just,
Oh, yeah.
yep, I'm just showing that, okay? Like I've done here. It's a bit tedious, but it's just making sure you're remembering the process. Right, so it equals 4.
Aren't they for completely different reasons?
Okay.
Those two times ones are completely different reasons.
Yeah, but they all came from the derivative of x, didn't it?
No, because the noun comes from differentiating.
Yeah, and they all
And
came
noun
from,
came from the actual.
well, that came from the derivative of x,
Yeah.
and that one came from the derivative of x plus 3. Okay, so applying your index clause and putting it back in this format here. Okay. Right, is everyone else following? Right, so that is. So note you could expand the functions, I've already said this, and differentiate using exponent rules, but like in B and C, it can be difficult to expand, so I suggest you just stick to the process of the product rule. Right, exercise 8.9 can now be attempted. Right, 8.9, now we're looking at the quotient rule. Quotient. And you've all done extension 1 polynomials, you should all be able to tell me what the quotient is. Anyone actually remember?
No.
Quotient.
How does it combine?
Yeah, it's involved division. So, we use the quotient rule when we have the division of two different functions of x. Okay? So, product rule, when you're doing the product of two different functions of x, and the quotient rule is when you are calculating the quotient of two functions of x. Okay, so remember when I said second times derivative of the first, first times derivative of the second. Same order, just a different thing you need to do at the end. Right, y dash. So second, g of x, times the derivative of the first. So first being the top, second being the bottom. minus. Alright, product rule is the plus, quotient rule is the minus. Okay, take away the first times the derivative of the second, and the extra thing you need is all over the second squared. So whatever's already on the bottom of the fraction, we need to square it. Okay, and that's also in your notes. So for both the product rule and the quotient rule, it's that process. Product rule has a plus between them. The quotient rule has a minus between them. And for the quotient rule, we need to square the second or square the bottom. Alright, let's have a look. Example A. Y equals 3x plus 1, take away 1, sorry. All over 4x plus 3. And after we finish parametrics, Robin and Michaela will be learning to graph. These sort of things. The rest of you just get free on that particular example. Okay, so the top is the first, okay, so that's the first, and the bottom is the second, and of course the top is f of x, and the bottom is g of x. If you prefer to remember them as f of x and g dash of x and all that sort of concept before here, okay, that's fine, go for it, alright, but I'll just keep quoting that to you, and that's just an alternate way for you to remember it. Right, derivative, y dash. So the second multiplied by the derivative of the first. So we have 4x plus 3 in bracket times the derivative of the first being the top of the fraction, times by 3. Take away for the quotient rule, the first, so the top, 3x take away 1 in bracket, times by the derivative of the second, derivative of the bottom, times 4. And you rewrite the denominator, 4x plus 3 to the power of 2. So you square the denominator. Okay, so I have quoted to you at the past, fractions always in simplest form. This is an example where I'm not requiring you to do that, okay? We are just assessing your differentiation skills. If you just ask to differentiate or find the first derivative, that's where you stop, okay? Tidy it up so it looks nicer than that. However, it'll be continuing on from that concept in your HSC course, okay? From that, you'll be expected to do more. Okay, and you will need to so that you can work through the question. Right, everyone following the process. Alright, let's try the next one then. Actually, before I do that, what does this tell me? The first derivative of any function tells me the equation of the gradient of the tangent. Come on. Thank you. Okay, it does not give you the gradient, it gives you the equation of the gradient, okay, unless the function itself was a straight line. Okay, so I think here it's pretty obvious that the function there is not a straight line. It's actually not a function technically. Alright, B, x squared, so y is x squared on x take away 6. Now in my notes, I haven't got them as y equals and x equals. You probably have the same in your textbook. Okay, so I'm just making the link between x's and y's. Alright, so in your answer, all you need to do is you wouldn't need to put this in there, okay, and just write everything else, alright, as you're working through the question. I'm just putting it there so that we can see the relation to what we're doing so far this topic. Alright, y dash, so start at the second times the derivative of the first. For the product rule, it is the takeaway. For the quotient rule, it is the takeaway. Don't listen to that first sentence. Get it out of your brains. I don't want to confuse you anymore. Times the first, multiplied by the derivative of the second. And then the extra step is you need to write the numerator and square it. Okay? So you're not expected to simplify the fraction, however, you can tidy that up a bit better than what I've got there. Alright? And that's what I'd like you all to do. Question? So, except for Amanda, what does this tell us?
Equation.
Yes?
Gradient of the tangent.
Equation, gradient, tangent. Okay, you need to remember that. Not quite. Not quite. We've got the extra couple of end of chapters of other chapters that we need to get to. Alright? But that'll be covered
You guys get to do the circle
next week.
geometry calculus question.
Hey?
The
Circle geometry? Yeah.
calculus question.
Yep. Alright, so we have 11 minutes. So you want 11
Can I
minutes
go
of work?
pee, please?
Hey?
Can I go pee, please?
P.
Pee.
P. P away.
Can I go to the toilet, please? That's
P away.
Huh?
P away.
Hurry up and go.